LIGO. So have you heard about LIGO? LIGO project? LIGO? So what is LIGO? Have you heard about that? So what is LIGO? So LIGO means, actually it's a kind of observatory. It's a kind of space observatory telescope kind of thing. So what is LIGO means? LIGO means laser interferometer gravitational wave observatory. LIGO, laser interferometer gravitational wave observatory. So that is LIGO. Okay. So what is the chief purpose of this LIGO? LIGO is a device. LIGO is a huge observatory or huge detector which helps in detection of some waves called gravitational waves. Okay. With the help of LIGO, LIGO is a observatory, LIGO is a device which is used to detect some waves called gravitational waves. Okay. So what are the machines, what are the tools or devices used in this observatory is laser interferometers. Laser interferometers. So that means laser interferometers are nothing but it is an investigative tool that is commonly used by the scientists to observe some hidden things or likewise. Okay. So what will happen here? So usually here we have to understand two important things. If we talk from the perspective of LIGO observatory, LIGO observatory, it is located at 3 places in international wide. Okay. So first place, if you see, LIGO is based on one thing, it is USA. In USA, we have a place called Hansford. Have you heard about Hansford? So at Hansford and Livingston. Hansford and Livingston. At this place, LIGO is based. Original LIGO is based. Okay. And along with USA, we in other 2 places also we have the LIGO project. So the next one is like, for example, in Italy. So in Italy, we have a place called Virgo. Okay. So at Virgo, we have this LIGO, laser interferometer observatory. So at Virgo, we have LIGO. Okay. Then in Japan, also we have one LIGO, laser interferometer gravitational wave observatory. So that is located at a place called Kagra. That is a place in Japan. So at present we have at 3 places we have the LIGO observatories. So fourth one, in India, we are also planning to have a LIGO observatory. That means that is called as LIGO India. So if we talk from India's perspective, we are planning to have the LIGO observatory at Hingoli district in Maharashtra. Okay, in Maharashtra, we are planning to just construct this LIGO observatory. Okay, so these are with respect to the location where they are located. Okay, what is it? It's a gravitational wave observatory. So how does that works? So let's try to understand. Here we have to understand 2 important things. So first thing is with respect to laser interferometers. What are laser interferometers? How they will work and what is their purpose? And next thing is we have to understand what are gravitational waves and why we have to understand the gravitational waves, when they have been predicted, and all those things we have to understand. Okay. So first, let us proceed with the interferometers. Okay. So in simple fashion to say what are interferometers. So interferometer, it's a kind of investigative tool. used by scientists. So what these interferometers will do, usually assume that when there are two light sources, okay, so if there is a light source which is giving the light, okay, and light is coming from this, and assume that there is another light source which is giving the light. So let's assume another light source. So it is giving the light for us. So what laser interferometers will do, it will try to merge these two light sources coming from different sources. Okay, so light coming from two different sources will be merged by interferometers, so that the light would be merged and it would be um, it would be framed into one spectrum, so that we can study about that. So that is the chief purpose. Okay, so that is the chief purpose of this laser interferometer. That means merging of the light coming from two different sources. So that is the chief work done by interferometers. So now what we will do here with respect to in LIGO, like we will have different light sources in this space. Okay, so we will try to capture that light sources, and we will try to assess that light sources by merging them in a different way. So when we do that, then we can decode that light sources. So by this process, what we have done, like we have recently in the year 2015 to 16, United States based LIGO, that is, which is located in Stanford and Livingston, it has recognized something called gravitational waves. Gravitational waves. Okay. So by this method, by doing this, they have found out that there are some things called gravitational waves, and they have disclosed that. So for this discovery, the LIGO has also got a good recognition. Okay. So here, gravitational waves. What are gravitational waves? So you simply remember, or you just imagine as if they are like normal waves which we get in water. So simply see, like take a bucket of water, and if you drop a stone in that, so then we can see some ripples flowing in the bucket of water. Can you see that? So can you recollect that? So in the similar fashion, gravitational waves are nothing but ripples, but they are in the space. Are you getting that? They are ripples that would be generated in this space. So how they would be generated, when they would be generated, and why they would be generated. So that is important. Like now, for example, you take a bucket of water and drop a stone, we have said. So here two bodies are colliding, that is, water is getting collided with the stone. So when two bodies are getting collided, when they are getting interfaced, at that interface we are getting the ripples. So that is how they are produced. In the similar fashion, gravitational waves are also like basic, they are ripples in the space-time. Ripples in space-time. Okay, so they would be generated. When they would be generated, usually these ripples would be generated when two large celestial bodies in the space gets collided. Are you getting that? Here we have said, like when we are dropping stone into water, then ripples are generated. Okay, in the similar fashion, assume there can be two large celestial bodies, like let's say for example black holes. There are some things called black holes. Okay, so one black hole may collide with another black hole. So during this process, there might be large energetic waves that would be generated. So that huge energetic, massive energetic ripples that are generated in this space, they are nothing but the gravitational waves. Space-time. Space-time means it will be defining from the perspective of, it's a three-dimensional definition, like where space would be the one dimension and time would be the dimension. So we will define, like for example, geological time scale, geological time, like space time. Are you getting? Space time means in the form of light years. We will say the denotation would be different. Okay, in simple fashion, you can remember like ripples that are generated in space. Okay, space time means with reference to time and with reference to space. We will club that. Okay, so likewise, so like when two large masses like black holes, when they collide, let's say I'm hypothetically just taking this as a black hole, okay, and this is a black hole, another black hole, okay. So when both of them gets collide, so then they will develop some ripples. So that ripples which are generated when these two black holes collides, so that is something, they are nothing but gravitational waves, okay. So that's how they will be produced, okay. So these two large masses can be anything. They can be white dwarf stars, they can be like supernova stars, they can be like black holes, so any large masses, okay. So for the first time, these gravitational waves have been predicted, existence of these gravitational waves have been, existence of these gravitational waves has been predicted by Albert Einstein. Albert Einstein in the year 1916. Albert Einstein in the year 1916, he predicted that there can be some things called gravitational waves. But he didn't use the word gravitational waves. He said that as it happening on the earth, there can be something, same kind of ripples that may happen in the space. So that's how he predicted. And he said, and for predicting this, Albert Einstein used a theory. So with his theory, there is a theory called Einstein's theory of general relativity. Okay, so Einstein's theory of general relativity. So I am writing down. Remember, read it as theory of general relativity. Einstein's theory of general relativity. So he is well known for this theory. So this theory is again based on Newton's law of gravity. Newton's law of gravity. So let's say, for example, in simple ways to say, what does this Einstein's theory of general relativity says is that, so simply it says that gravitational waves will not disperse as they travel through the space, unlike the light waves. Say there are two types of waves. One is we have light waves, okay, and other one is gravitational waves. Gravitational waves. So what, according to the theory of general relativity, according to the theory of general relativity, it is very well known to us, to you generally, that when a light source is coming from one point, when a light source is there, light will generally, it will disperse when it travels from one medium to another medium. So it is understood, dispersion of light. We have that, we know that. So light will be dispersed towards into various components. Okay, so that is well understood to us. But what, according to general relativity theory, he related this kind of thing with respect to gravitational waves. So according to theory of general relativity, it says that unlike light waves, gravitational waves will not disperse. Gravitational waves will not disperse. Are you getting that? Gravitational waves will not disperse like the light waves. Like how light waves will disperse, that process will not happen. So that is the central and core theme of the theory of general relativity in the life cycle of the star. Okay. So what will happen here? Black hole, it is also known as neutron star. That means when usually it is understood to you that stars will contain generally some stars will glitter. So for glittering, that means there would be a constant fuel that would be burning inside that one. So usually hydrogen and helium. Hydrogen and helium. So these are the two fuel materials that would be present in a star. Okay, so fuels that are present in the star. So when this star upon the space time, when the time moves, generally what will happen, the fuel that is present within this star also get exhausted. Okay, so assume that over a period of time, I'm not saying years, one or 2 years, but over a period of geological time, so then the fuel that is present within this star, it will get exhausted. So there would be a point where entire fuel will be exhausted, where it remains like a simple body. Can you able to understand that? So that stage is known as the final or dead stage of the star, that is known as neutron star stage. Okay, and this stage is also called by other name called black hole stage. Okay, when a star reaches to this stage, what will happen? So at this stage, assume that if this is that star, at this stage, that means at the last stage of the star, so this stage would be characterized by very high gravity. Very high gravity. Gravitational pull of force would be such a high that whatever enters into this body, whatever enters into this celestial body will never escape from outside. Like let's say for example, any matter that enters into this black hole would be engulfed and it will not be liberated. Are you getting? Even light cannot escape from this. That means such would be the extremity of this gravity. So that much gravity would be there, everything would be sucked up and it would be absorbed and it will never be released out. So we are calling them as black holes because even light also cannot escape from this. So when can we see something? When light emits from something, then only we can see things. When these things are not, when it captures even light also, and it also won't allow light to escape, obviously we will see it as a dark body. That's it. And we cannot see it generally. We can see it with some telescopes only. So that is one thing. So that is the thing. So that's why we are calling them as black holes, because whatever enters into it, it will not be escaped from that. So including light. So as light is also being trapped and light also cannot escape, so cannot escape, they will look black. That means it looks like that. So that is the way that thing. So that means with respect to gravitational pull of attraction, so we are saying them and we remember like this. So one thing that we can find these black holes only through space telescopes. This is also another thing that you have to remember. Okay, so when such kind of black holes collide, then we can expect the formation of gravitational waves. Okay, so that is one thing. So now with this, we have a project called the LIGO India project. Okay, so what is LIGO India project? So LIGO India project, when we talk from the LIGO India project, we are planning to just launch this LIGO India at a district called Hingoli district of Maharashtra. Okay, so who are involved in this? So LIGO India is envisaged as a collaborative project between a consortium of Indian research institutions. Consortium means group of research institutes. So what are those? Means we have for these institutions involved. So one is like LIGO, that is international US based LIGO. So that is one thing. And apart from that, we have Raja Ramanna Center for Advanced Technology. So this Raja Ramanna for Advanced Center for Technology is located at Indore, Madhya Pradesh. So this institution is organized, it is involved in this project, and along with that, there is Inter-University Center for Astronomy and Astrophysics, IUCAA. Inter-University Center for Astronomy and Astrophysics. So it is a Pune-based organization, scientific research organization. So it is also involved in the project. Okay, remember, institutes are also important. Okay, so what are like what are the organizations that are involved in the project? That can also a question. Okay, remember from that perspective. So next one is like we have Institute for Plasma Research. Okay, so IPR. So it is an organization based on Gandhinagar, Gujarat. So these are some of the organizations that are research organizations that are involved in the process of development of this LIGO India project. Okay, so we have said that it is project between consortium of Indian research institutions. These are those research institutions. And the purpose, what does this do? So these also mentioned here. Like for example, RRCAT, Rajaramana Institute, what it will do? It provides its expertise in lasers and laser technology. We see LIGO, Laser Interferometer Observatory. Okay, LIGO, laser technology. So it provides its expertise in laser technology. Then in the similar fashion, IUCEA. So what does it do? It is a Pune-based organization. What it will do? It will provide the scientific teams and scientific data and data analysis. It would be done by this one. Okay, so laser technology it is providing. So data with respect to data analysis, it is handling the role. And we have Plasma Research Institute, IPR. So it is contributing the cryogenic and high vacuum systems for the project. So cryogenic technology is provided by Plasma Research. Okay, so Plasma Research, IPR. So these are the purposes that they will handle in this project. Okay, so that is one. So then, if we talk from the perspective of India's perspective, which departments of the governments are involved? Remember, two important government organizations have been involved. Departments have been involved. One is Department of Atomic Energy and Department of Space Technology. Okay, so Science Technology, Department of Atomic Energy and Department of Science Technology. So these are the two departments from the government of India. They are involved in this project. Okay, so that can be another important thing. So along with that, we have an MOU with this NSF USA. So because LIGO is basically it is US based project. Okay, so National Science Foundation of USA, and that is with this collaboration we are making it. Okay, so that is one. So remember, these are some aspects that you have to remember with respect to that LIGO project. Okay, so then if we talk from the perspective of this LIGO, so we have also saw international presence also. So remember, these LIGO projects are based in USA, and we have Italy and Japan at 3 places. So this will be the 4th one. So that is one. So this is with respect to the LIGO India project. Okay, so like see how these ripples, these are two black holes, when they collide, so then waves will be generated. Now can you see the ripples? So how these ripples will be generated? This is how they will be repeated. They will be generated. So see, this is one light source, this is another light source. So light would be grabbed from this one, light would be grabbed from this one, and here interferometers would be there. These interferometers, what they will do? They will merge the two light sources and they will decode, they will frame it into a kind of decodable things, so that we can study them. And in this, if gravitational waves are there, we can observe when gravitational waves have been produced. So that's how. So they will split the light into some readable form, so that identifiable form, so that they will be observed. So that's how this LIGO project will work. Okay.